Welcome to the mini lecture for Chapter 3, National Income. Let's get right to it. All right, let's see. The critical things for you to know. In this first simple model, very simple model, we assume that output, which is y, is a function of two things, capital and labor, that's it. Notice that we have this bar over some of the variables. That means we're assuming it to be fixed. So here, we assume capital is fixed. It's exogenous to the model. It's just a given, and it doesn't change. Labor, same thing. Well, if all of the inputs are fixed, then the output has to be fixed. There is no economic growth in this model. It's completely static. Also, notice we're not specifying the functional form. This could be, for example, y equals k squared plus 3l. Take the amount of capital in whatever unit, square it, the number of units of labor times 3, add them together. That's not a reasonable functional form, but the point is we're just not specifying what the functional form is. We're just getting the inputs and outputs of the function squared away. Okay. Marginal product of labor. If you add one more unit of labor to the economy, how much more output do you get? Well, you can see that it's declining. The first unit gets you that unit of labor. Adding that one gets you that much additional output. But after you already have a lot of labor, adding one more unit only gets you that much. Because it's declining marginal product. Just in case you were curious about why there is a declining marginal product of labor and of capital, here's an example. Let's assume that we're going to change labor and add more and more labor while holding the level of capital fixed. Okay, here's where we start. 3 machines, that's 3 units of capital, and 1 unit of labor. Production is obviously going to be pretty low because you have one person trying to run 3 machines at the same time. Not easy to do. Okay, so we add 1 unit of labor. Production goes up by a lot because now this machine can be used. We add 1 more unit of labor. Production goes up a bunch again. But if we keep going, let's say instead of 1 person, person on each machine, we have 2. So now we've gone from 3 units of labor to 6. Well, this person, and of course that one and that one, hiring them does not increase production that much because it takes 1 person to run a machine. It does, however, increase production some. Let's assume that, once in a while, this worker would get sick or need to take a break. Well, then this worker could step in and run the machine. So yes, production does increase, but not by a ton. Let's hire more people. So now you have the person running the machine and 2 extras. Production will go up because there's going to be some day when that worker is sick, and that worker, has something else to do, and so this worker can run the machine. The marginal product will go up, just not very much at all. And if you keep going, you run into this situation where you have, I'm not even going to count them, a lot of people, a very high labor to capital ratio. Now, in this case, you've gone so far that not only will adding one more person not increase output, it'll probably make it go down because people will be tripping over each other. So each additional person you add, for each additional person you add, the marginal product of labor, it goes up mostly, but by less and less and less. Here, actually, this would eventually curve back down that way when adding additional people would actually hurt production, not just help very little. All right, and capital works the same way. Let's see. What else might you have difficulty with? Okay. We're assuming this is a closed economy. I didn't mention that before. Closed, meaning no international trade. It's a very simple model where there's only capital, there's only labor, and they determine output. Now let's look at consumption. That's how much the economy's producing. Where does it go? Well, consumption is, if I can find it, total output is equal to C plus I plus G plus NX. Consumption plus investment plus government spending plus net exports. But this is a closed economy. No imports, no exports. So it's just that. Consumption. Disposable income is consumption minus taxes. And here's an important concept, a very important concept. The marginal propensity to consume. This is a number, usually between 0 and 1. It means if you increase disposable income by $1, how much will consumption go up? If I give you $1, how much of it will you spend? It's generally modeled as between 0 and 1 because you're going to save some of it, maybe a little, maybe a lot. But consumption will not go up by the same amount. Here, consumption is a function of disposable income. some fraction of your disposable income you'll consume. And disposable income is total income minus what goes to taxes. Here, this slope, something less than 45 degrees. So as disposable income goes up, let's say by that much, consumption will increase, but only by that much, which is a little bit less than disposable income went up, because the marginal product to consume is a little less than 1. Investment, government spending. Market for goods and services. What is total demand? Well, it's consumption, which is a function of disposable income, plus investment, which is a function of the interest rate. It's just the price of borrowing money, plus government spending, which is a function of nothing. Okay, so that's the demand side. What is the supply side? How much stuff is being produced? That's a function of capital and labor. Therefore, if supply and demand are in equilibrium, this must be true. You're just substituting these into that. Total output must equal consumption plus investment plus government. And it is the interest. Now, what makes this equilibrium? How do you get to an equilibrium? It's this, the interest rate. Because that changes the amount of investment. We're assuming that government spending is just fixed. It's exogenous. Taxes are fixed. Output, well, that's determined by capital and labor, so that's fixed because each of them is fixed. Therefore, the only thing that's free to vary is investment to bring this system into equilibrium. And the only thing in this model that determines investment is the interest rate. So it's the role of the interest rate to bring aggregate supply and aggregate demand into equilibrium. Let's see. Public savings. This gives some people a little trouble. Savings must equal investment. You can only invest some money if you first save it. Private savings is pretty straightforward. That's the total amount of wealth you have available for either consumption or investment. It's your total income minus taxes. Well, if you take the total and you subtract off consumption, what's left is savings. You have $100 income. You pay $20 in taxes. So now you have 80. Of that 80, you consume 50. Private savings, $30 that you stick in the bank. Now, public savings. Public savings is a little more difficult to imagine because it kind of never happens. But hypothetically, if the government were to tax away $100 and then spend $90, it would have $10 left over. That would be saving on a national level, money that's not consumed. Total national savings is this term, private savings, which is here, plus public savings, which is here. Cancel out, and you get that. When I said public savings doesn't happen, well, it's because this equation is still true. It's just government spending is, well, in my lifetime, always been bigger than the amount taken in by taxes. So public savings is actually negative, but you still add them together. What else do you need to know? Oh, the supply of loanable funds. Well, national savings don't depend on the interest rate in this model. So the supply of loanable funds is fixed. It's a vertical line. This is the quantity of loanable funds. That's the interest rate, their price. But we're assuming that the supply here is completely impervious to price. It is completely inelastic. And the supply of loanable funds is all the output of the economy minus consumption minus government. What's left is savings and thus investment. Well, if that's the supply of loanable funds, what's the demand for loanable funds? That's investment. People supply loanable funds by savings. People consume, in a sense, loanable funds by borrowing it and investing it. So we already know the supply is a vertical line in this simple model. The demand for investment funds, well, that is a function of the interest rate. If interest rate is low, people will want to borrow and invest a lot. If the interest rate is high, people will want to borrow and invest very little. So we now have a very simple supply curve and a demand curve and equilibrium. That is the equilibrium interest rate. So from this perspective, the interest rate, well, actually here, it explains it, is to bring the supply and demand in the market for loanable funds into equilibrium. And if you have one market in equilibrium, because, let me go back to that graph. Where is it? Give me just a moment. Well, this isn't the graph, but it's close enough. In equilibrium, supply and demand have to balance. Supply is output, some function of capital and labor. Demand is all the spending added up. Total consumption, which is the total value of the economy, is C plus I plus G plus the non-existent NX. Therefore, C plus I plus G must equal total output. Consumption equals production. For all of this, the only thing that's free to vary in this model to bring it into equilibrium is the interest rate. It brings both sides into balance with each other. Let's see. Here we go. Here's a nice example. What happens if there's an increase in demand for investment? Some technological breakthrough makes investments more profitable. Okay, if we move from this first demand for investment funds to this second demand, well, we know that the supply of loanable funds in this model is just fixed because all the inputs are fixed. Then we're going to go from this equilibrium to this equilibrium. And the interest rate will go from R1 to R2. It's a very simple supply and demand graph. Okay, we're still sort of in the part of the course where we're learning mostly vocabulary of macroeconomics. We will take these basic building blocks in the next couple of weeks and start putting them together into models that make interesting predictions. Thanks.